good day everyone. Thank you for having me. My name is Rosaline. However, you can call me Rose. I also prefer that. On the other hand, I'm going to be speaking to you today with regards to mathematical reasoning, principally with reference to inductive reasoning. I know many of you are asking, what is mathematical reasoning? What is the difference between deductive reasoning as well as inductive reasoning? As per the fact that I have heard many students, eminently freshman college students, I am also a freshman college students, are confused about what mathematical reasoning really means. How we're going to use it, into the bargain, what is its relativeness to inductive reasoning. Now, if you're one of those people who have questions, together with if you want to know the real momentous in this study, just keep watching. Before I'll start to show you my presentation, let us first talk about mathematical reasoning. What is mathematical reasoning? Mathematical reasoning is the critical skill that enables a student to make use of all other mathematical skills. With the development of mathematical reasoning, students recognize that mathematics makes sense together with can be understood. Now that you know what mathematical reasoning means, it will be easier for you to understand what we will discuss next. I have prepared slides so that everyone can better understand the main points of my discussion. Inductive reasoning, mathematics in the modern world. Introduction. Inductive reasoning organizes what we observe into succinct geometric hypotheses that we can prove using other more reliable methods, whether we know it or not. The process of inductive reasoning almost always corresponds to the way we form ideas about things. Furthermore, just as deductive arguments are meant to prove a conclusion, inductive arguments are meant to predict a conclusion. From the aforementioned phrase to predict a conclusion, well, now you can easily understand what inductive reasoning really means. They do not create a definite answer for the premises. Nevertheless, they try to show that the conclusion is the most probable one given the premises. What is inductive reasoning? From the aforementioned, I told you, inductive arguments come to predict a conclusion. Now, what is inductive reasoning in math? For further explanation as well as better understand the main point of my slide, in math, inductive reasoning involves taking a specific truth, which is known to be true, and then applying this truth to more general concepts. By doing this, the mathematician attempts to construct logical conclusions. While the conclusion that is reached may be likely, it is also possible that the conclusion could be incorrect due to some factor that has been unaccounted for. Generally speaking, the use of inductive reasoning is extremely common in mathematical proofs. Inductive reasoning often leads to the discovery of mathematical truths which are then applied to other aspects of math through deductive reasoning. Okay, from the aforementioned that I have told you, inductive reasoning in theory has three momentous things that you have to know as well as to practice. So, what are the three things that we need to remember when we talk about inductive reasoning? As you've perceived, it is written there in my slide. In addition, you can see that there are clip arts being that case you could better understand my point of view. We have the specific observation, pattern recognition, as well as general conclusion. Specific observation, inductive reasoning begins with observations that are specific and limited in scope and proceeds to a generalized conclusion that is likely but not certain in light of accumulated evidence. You could say that inductive reasoning moves from the specific to the general. Pattern recognition, to find patterns, on the contrary, figure out in a logical way what those patterns suggest about what will happen next. In a broad sense, pattern recognition as well as inductive thinking form the basis for all scientific inquiry. General conclusion, a conclusion you reach using inductive reasoning, is called a conjecture. So now, since I have explained the three momentous things that you have to remember when we talk about inductive reasoning, we are now moving on to its examples, being in that case, you could better understand my point of view. Inductive reasoning examples. This section will cover one example only. Inductive reasoning in theory, example 1. A specific observation. Cheap medications A and B both cause major side effects. Pattern recognition. All observed cheap medications cause major side effects. General conclusion. All cheap medications cause major side effects. As you have perceived, the first example elucidates the methodologies of an inductive argument on the grounds that the slide shows you what is the process or method of creating an inductive reasoning. Moving on to the next example, this section will cover inductive reasoning in numbers. Of course, inductive reasoning is not just in sentences, on the contrary, also in numbers. Inductive reasoning in numbers, example 2. 3, 6, 9, 12. Pattern observe, add to the previous term. Conjecture, the next number is 15. This example predicts what is the next number. As a result of that, it is inductive reasoning. Another example. 3 times negative 4 is equal to negative 12. 2 times negative 4 is equal to negative 8. 1 times negative 4 is equal to negative 4. 0 times negative 4 is equal to 0. Negative 1 times negative 4 is equal to 4. Negative 2 times negative 4 is equal to positive 8. Negative 3 times negative 4 is equal to positive 12. Every time the factor on the left comes to decrease by 1, the answer corresponds to increase by 4. As you have perceived that there is a pattern in this example. On the contrary, the pattern suggests that a negative times a negative is a positive. Moving on to the next example. Inductive reasoning in numbers, example 4. Boss to employee. Ace has a tattoo of an anchor on his name. He probably served in the Navy. This statement is ambiguous. This example reached a general conclusion as an alternative conjecture. As a result of that, it corresponds to inductive reasoning. Moving on to the next example. Inductive reasoning, example 5. The first mathematician who ever studied triangle may have noticed that 3 random triangles in front of him all had angle measurements which added up to 180 degrees. He may have then theorized that perhaps this is true for every triangle ever constructed and for every triangle that ever will be constructed. This is of course something that mathematicians now accept as an irrefutable truth. Nevertheless, at one point in human history, it was certainly not known that the angles in any given triangle will add up to 180 degrees. Moving on to the next example. Example 6. 1 plus 3 is equal to 4. 3 plus 5 is equal to 8. 5 plus 7 is equal to 12. The sum of two odd numbers is always even. A simple example of inductive reasoning in mathematics, right? It's really simple. You start with the math facts. By this, you propose that the sum of two odd numbers is always even. Start with a specific true statement. 1 is odd and 3 is odd, the sum of which is 4, an even number. Now, show it is true for the rest. You could use a multitude of examples, or you could make the generalization that an odd number is just an even number plus 1. Thus, adding two odd numbers is really just adding two even numbers plus 2, and the sum of two even numbers is always even. Therefore, the sum of two odd numbers is also even. Starting with a specific observation, we were able to use inductive reasoning and apply it to the entire population of odd numbers. Here's an easy way to remember the direction of inductive reasoning. I and N, in the word inductive, is the prefix for increase, which means to get bigger. Thus, inductive reasoning means to start small and get bigger. Now, moving on to the next example, we have example 7. If a child has a dog at home, she knows dogs have fur, 4 legs, and a tail. If a child were to be introduced to a cat, that child may extremely well assume that cat is a dog. Owing to the fact that the cat has fur, 4 legs, and a tail, and the child's experience this means dog, the child induces from her specific scenario something about a much larger population. Moving on to the next example. Example 8. In the summer, there are ducks on our pond. Therefore, summer will bring ducks to our pond. In causal inference inductive reasoning, you have to use inductive logic to draw a causal link between a premise and hypothesis. And this is one of the examples of it. Now moving on to the next example. Example 9. You know 2 men from England who love soccer. You meet another man who states he is from England. You're shocked to find out he does not like soccer. How is that supposed to happen, right? Were you surprised? By inductive reasoning, you came to a specific conclusion about the entire population of English males. On the contrary, you were wrong. You were wrong. Not all inductive reasoning is wrong though. As the consequence of that, the premise is broader. It can lead to inaccurate conclusions. Often in the real world, this is seen as jumping to conclusions. Moving on to the next example. The last example. Example 10. Most of snowstorms come from the north. It's starting to snow. This snowstorm must be coming from the north. The inductive reasoning may be true. On the contrary, it's lacking enough evidence to be universally true. Further, something would be required. Always be required. Now we've come to reach what is inductive reasoning really means. We have discussed its definition as well as examples. Nevertheless, to better understand this topic, I have prepared a conclusion for our discussion. There you go. Conclusion. Inductive reasoning conclusion. Inductive reasoning begins with observations that are specific as well as limited in scope. In addition, proceeds to generalized conclusion that is likely, nevertheless not certain, in light of accumulated evidence. You can say that inductive reasoning moves from the specific to the general. Mathematically speaking, inductive reasoning might take this form. Step 1. Show that something is true for a specific item. Step 2. Show that if it is true for one, then it must be true for the rest. And this is where my discussion will end. Again, I am Rosaline from the BSBA department, and thank you for watching. Hope you like it.